Okay, so hi, we're going to try and do question 6 from the homework I set you. Pretty straightforward once you get the hang of what's going on here. So I'm going to draw in a line BAD, such that D is a point on the line here, and it means that AD is equal to AB. That's clearly brilliant, which gives us this here. Now the question is asking us to focus on areas, and the area of triangle ABD is equal to a half. Now this line down here would refer to as C because it's opposite to angle C. So we get half C squared sine A using the formula for the area of a triangle. The other formula for the area of a triangle is half base times height. I'm going to use that formula to get the area of ABC. So a half base C times the height, which is A. Okay, so we know that the area of the top triangle, ABD, is half of the area of the large triangle. So a half of triangle ABC is equal to triangle ABD. And so, substituting in our numbers, we get a quarter of CA, or AC if you prefer, is equal to a half C squared sine A, which we can now take and say times both sides by 4. CA, or AC, equals 2 C squared sine A. This is starting to look like what we wanted. Let's divide both sides by 2C squared. So AC over 2C squared equals sine A. This is good presentation. And then next we will cancel. That'll give us, I didn't mean to divide by the 2. I only want to divide by, so I'll times both sides by 2 and divide through. That gets me AC, A over C equals 2 sine A. A over C, I can write that instead as tan of angle A, because A is the length here, which is the opposite. C is the adjacent, so we've got opposite over adjacent, which is tan of A. So tan A equals 2 sine A as required. And now on to part B. So let me just clear the screen. We're asked to solve tan A equals 2 sine A. So I'm going to start off by getting everything onto one side. So 0 equals 2 sine A minus tan A. Easy enough. I'd like to rewrite this so that everything is in sines and coses. Okay, and now factorising that, I get 0 equals sine A, brackets 2 minus 1 over cos A, which tells me therefore that sine A equals 0, which means that A equals 0. Or 2 minus 1 over cos A equals 0. So 1 over cos A equals 2, which means that cos A equals a half, which means that A equals 60. Those are the only solutions between 0 and 90, and there are 2 of them, as required. The final part of the question says which one is appropriate. Well, obviously, A can't equal 0 since we actually have a triangle. Finished. Good.